The third option, nice option, is to work in an observatory, usually in very nice sunny locations because they need as little cloud cover as possible. So you get places like Hawaii and the Canaries that have, or South America, where they're looking up into space from the Earth, and they're looking at what's out there. Or you could use data that's coming down from satellites in space and be involved in as an environmental scientist. So looking at what's happened to the polar ice cap, for example, or looking at smog levels or pollution levels. So this is a real growth area, I would say, if you're interested. And of course, you can be an academic as well. You can take someone's job here in Trinity and become a lecturer or a professor. But there's not only Trinity, there's a lot of the colleges around Ireland have departments of astrophysics or astronomy. So if that interests you, that's also a career option. So, as I say, ESA is an organization I've worked with. They've got a number of locations around Europe, and they've got one in South America. So they do different things. They do technology development, space operations, that's where they control it, the spacecraft. Earth observation, if you want to look down at the polar ice caps or whatever. Astronaut training, it's out there. Astronomy, and the launch site, as I say, is in South America. That's where the rockets actually go up. Life as a research scientist, that's what I do. So I don't work on space projects the whole time, but you take the money from where it comes from. So we've had some funding from the European Space Agency. But the type of things we do is, we look at what are the scientific needs out there, who's giving the money, who's funding us, what are the economic and scientific needs. We come up with a plan. We try to design a solution. If we're making devices, we fabricate them. We've got advanced test facilities and fabrication facilities. We test them. And then, okay, you get the odd chance to go to nice places to present your work or for meetings, whatever. So it's a good mix if you want to be a research scientist. And as I say, it's not only space technology work. At the moment, I'm working in solar cells, so things vary. But you do get the chance to do a lot of different things. So if you're interested, I would say start today. Go to the European Space Agency website. There's a huge amount of information there. If you're interested in the career side of things, there's a career section where even as a student, you can come in on board. If you want to do an internship, you can go over to the Netherlands, Germany, wherever. You sit in and annoy somebody for the day, watch how they do their work. If you want to do a postgraduate study there, you can do that. If you want to do postdoctoral study, research, whatever, there are a number of locations around. And you can see even there's programs for students to get involved. There was a call there for moon missions, for a project where students would actually design a satellite that would go up to the moon. So they really do want to engage with the public. So if you are interested, I would suggest go to the European Space Agency website and take a look. So alternatively, if you want to go for something a little different, you can also join this, do a 520-day Mars simulation mission. So if anybody wants to be locked into a room for, how does that, a year and a half, nearly 2 years, and feel what it's like to survive on space, and I'm sure in Mars, and I'm sure you'll be well paid for it, then that's also an option. So that's pretty much it, folks. Thanks for your time, and if you have any questions, shout. Yep.
What kind of subjects would you suggest if students are interested in a career in this area? What subjects would you choose for going on to third level? What would be?
Believe it or not, science. Yeah, it's of course it's science, maths. Geography. If you want to be an environmental scientist, if you want to look at things like polar ice caps and all that, you would take geography. Biology is important because if you want to look at, let's say, pollutants in the atmosphere, or if you're interested in looking at different environments on different planets. But of course, it is going to be science in whatever form. Physics is a great grounding because it gets your head around all the background you need to, if you're interested in lift-off devices, or if you want to make little devices that go up into space, solar cells or whatever it may be. Chemistry is important if you want to develop new materials for space. Let's say you want to develop a new glue that's going to stick your solar cell onto the panel that goes up onto the satellite. You've got to be good at chemistry, and you've got to know, okay, what material is going to stick well, but it's also going to conduct heat away, and it's also going to be radiation hard. So it generally is the science subjects, but it's whatever takes your fancy. You can take it on. And of course, applied maths is also a great one as well. Yes, good-looking man here in the audience.
No, I was just wondering, I was looking back at your picture of Captain Kirk and his miniature mobile phone.
Yeah.
Do you have any idea what the next big technology could be that could come out of space that we could be using in the next few years?
Laser energy transmission. There is serious. They are seriously considering transmitting energy from space using a laser or microwave technology. So you would have solar cells up on the moon, solar panels, massive areas collecting sunlight non-stop and beaming it down to Earth. Now, it's a crazy idea. You've got to think about, okay, what's going to happen when my energy hits the atmosphere? Is it going to dissipate? Is the light going to be reflected around the place? But alternatively, they'll store it up in the moon. But there's a big push, and it's quite aggressive. You know, people are thinking the moon is the next place we've got to capture, we've got to take over. So there are some crazy ideas like that, but there are also more down-to-earth stuff, like, let's say, the radiation monitor that's developed in Tyndall. It's likely that could have, things like that, monitors and sensors could have much more applications down on Earth. You know, when you're in space and when you're an astronaut, you have sensors all over to monitor your body, what's happening to your body in space. Photodynamic therapy, for example, looking at what's happened to your bones. They use lasers to monitor your bone density. So things like that could be a monitor for osteoporosis, for example. There's potentially lots. I'd suggest take a look at the spin-off website on either NASA or ESA, and you'll get a laugh out of it if nothing else.